10,000 logs, laid side by side across a swamp, each one 6 to 12 inches in diameter, 12 to 16 feet long, cut from the nearest forest, and dragged to the road site by teams of oxen or horses. The logs placed perpendicular to the direction of travel, packed tightly together, sometimes secured with wooden pins or simply left to rest on the mud. This was a road, a wooden highway crossing terrain that was otherwise impassable. Horses and wagons would travel over these logs, the wheels bumping from log to log, the entire surface shifting and settling under the weight. The logs would sink into the mud, they'd rot, they'd break, and workers would cut more logs and lay them on top of the old ones, building up layers of timber until the road was stable enough for regular use. This was how America crossed its swamps before modern engineering. 10,000 logs per mile, all cut by hand, all laid by muscle power, creating roads that would last maybe 5 years before needing to be completely rebuilt. This was America from the 1600s through the early 1900s, and large portions of the country were swamp, the coastal lowlands, the river valleys, the lake regions of the upper Midwest. These areas had valuable resources, timber, farmland, minerals, but they were inaccessible because the ground was too soft to support wagon traffic. A horse pulling a loaded wagon would sink to its belly in mud. The wagon wheels would bog down. Progress would be impossible. The solution was the corduroy road, a surface made entirely from logs laid crosswise on the soft ground, creating a rigid platform that could support vehicles. Could you really build a functional road from 10,000 logs? Could wooden poles laid on mud actually support the weight of loaded wagons and teams of horses? And could you maintain such a road, replacing rotted logs and fixing damage for years of continuous use? The answer is yes. The evidence exists in historical accounts, in old photographs showing these wooden highways stretching across swamps, and in the rare remaining sections of corduroy road that have been preserved or that still exist buried under later road construction. Before we get to how corduroy roads were built, you need to understand why they were necessary and what made swamps such a barrier to transportation. Because this isn't obvious to modern people who've only experienced paved roads. Swamps aren't just wet ground. They're fundamentally unstable terrain where the normal rules of road construction don't work. A swamp is land where the water table is at or above the surface. The ground is saturated with water. The soil is often organic, decomposed plant material rather than mineral soil, which makes it extremely soft and compressible. When you put weight on swamp ground, it doesn't just compact like normal soil. It displaces. The soft material squeezes out from under the load, creating a depression. Put a horse on swamp ground, and it sinks. Put a wagon on swamp ground, and it bogs down completely. Normal road building techniques don't work in swamps. You can't grade a road because there's no solid ground to grade. You can't compact the surface because there's nothing to compact. You can't build a raised embankment because the soft ground won't support the weight and the embankment will just sink into the swamp. The only solution is to create a rigid platform that bridges across the soft ground, distributing load over a wide area. That's what a corduroy road does. The construction technique for a corduroy road was simple in concept, but demanding in execution. Workers would cut logs from nearby forests, whatever trees were available and suitable. The ideal corduroy log was straight, 6 to 12 inches in diameter and 12 to 16 feet long. Larger logs were harder to handle. Smaller logs weren't strong enough. The length had to span the width of the road, which was typically 12 to 14 feet to allow wagon passage. The cutting of logs for a corduroy road followed the same basic process as any logging operation. Felling crews would go into the forest, mark suitable trees, and cut them down using axes and crosscut saws. The trees would be delimbed and bucked to length. Then the logs would be dragged to the road site using horse or ox teams. The hauling was often the most difficult part because you were dragging logs through the same swamp terrain that made the road necessary in the first place. The laying of the logs was straightforward but labor-intensive. Workers would start at one end of the section to be corduroyed. They'd position the first log perpendicular to the direction of travel, Then they'd place the next log immediately adjacent, packing it tight against the first. Then the next, and the next, log after log, side by side, until the road section was complete. No mortar, no fasteners in most cases, just logs resting on the ground, held in place by their own weight and by friction against adjacent logs. The actual technique for positioning logs required coordination and specific procedures that workers learned through experience. The first log in a section set the angle and alignment for all subsequent logs. If it was placed even slightly skewed, every following log would follow that error, resulting in a road that curved or twisted. Experienced crews would use a compass or sight along the intended road direction to ensure the first log was placed precisely perpendicular. Moving the logs into position was itself a major task. A 12-foot log of 9-inch diameter, if it's wet pine or oak, weighs 200 to 300 pounds. And workers couldn't simply carry it. The standard technique was to use horses or oxen with chains. The animal would drag the log to the approximate position. Then workers would use peavies, hand tools with a hooked arm and a pivoting catch, to roll and position the log precisely. A crew of 3 or 4 men with peavies could maneuver a heavy log into exact position in a few minutes. The peavey technique was critical to efficient corduroy construction. One worker would position the peavey point into the log near one end. Another would do the same at the other end. They'd coordinate their leverage, rolling the log into position. The pivoting catch on the peavey would grip the log when force was applied, preventing slippage. An experienced crew could position logs with remarkable precision using just these hand tools. The spacing between logs was critical. Gaps meant wagon wheels could drop between logs, potentially breaking the wheel or injuring the horse. The logs had to be tightly fitted. But wood is irregular. Logs have taper. They're larger at one end than the other. They're not perfectly straight. They're not perfectly round. Getting them to fit tightly required adjusting their position, sometimes trimming high spots with axes, sometimes driving wedges between logs to force them together. The standard practice for dealing with taper was to alternate log orientation. One log would be placed with its large end facing north, the next with large end south, alternating down the entire road length. This balanced the taper effect and helped keep the road surface relatively level. Without this alternation, on one side of the road would be noticeably higher than the other, creating a sloped surface that would be difficult for wagons to navigate. The trimming of logs to fit was done with broadexes. If 2 logs had a large gap between them, a worker would take a broadex and flatten the sides of the logs where they met, removing just enough wood to allow them to fit tightly. This was skilled work. Remove too much, and you create a weak point. Too little, and the gap remains. The worker had to judge by eye how much wood to remove and execute the cuts precisely. Some corduroy roads used a technique called pinning to secure the logs. After logs were positioned, workers would drill holes through adjacent logs using large augers. Then they'd drive wooden pins, typically hardwood pins 2 inches in diameter, through the holes, connecting the logs. As the pins prevented the logs from shifting apart under traffic. This technique was more labor-intensive but produced a more stable road surface. It was typically used on roads that would carry heavy traffic or heavy loads, such as logging roads. The drainage considerations for corduroy roads were critical to their longevity. Water pooling on the road surface would accelerate rot. The standard solution was to crown the road, make it slightly higher in the center than at the edges, so water would drain off to the sides. This was accomplished by using slightly larger logs in the center of the road and smaller logs toward the edges, creating a gentle dome shape to the surface. In areas where water flow crossed the road line, workers would build culverts. These were simple structures, logs laid parallel to the road direction at the drainage point, creating a tunnel through which water could flow. The corduroy logs would be laid over the culvert logs, spanning the gap. This allowed water to pass under the road rather than pooling on the surface. Without culverts, water crossing the road would erode the foundation and cause the road to fail rapidly. The labor requirements for building a corduroy road were substantial. A crew of 20 workers might be able to lay 200 to 300 feet of corduroy road in a day under good conditions. That's cutting and hauling the logs, positioning them, adjusting fit. At that rate, building a mile of corduroy road would take about 3 weeks for a single crew. But most corduroy road projects use multiple crews working simultaneously on different sections, which shortened the calendar time even if it didn't reduce the total labor required. The number of logs needed for a mile of corduroy road depends on the diameter of the logs and how tightly they're fitted. For logs averaging 9 inches in diameter, laid tightly, you'd need approximately 14 logs per foot of road length. For a 12-foot wide road, that's 168 logs per foot of road, multiplied by 5,280 feet per mile, and you get approximately 887,000 logs per mile. But that's if every log were 9 inches exactly and perfectly fitted. In reality, with variations in log diameter, gaps in fitting, and the need to overlap logs at road edges, the number was closer to 10,000 logs per mile. 10,000 logs represents roughly 250 acres of forest if you're taking 50 trees per acre. That's a significant amount of timber for a single mile of road. For a corduroy road project extending 10 or 20 miles, you'd clear thousands of acres of forest. The environmental impact in the immediate area of construction was severe. Complete deforestation of the corridor needed for the road, plus the adjacent land from which logs were taken. The workers who built corduroy roads were often settlers or farmers who needed the road for their own use. In newly settled areas, the community would organize a road building effort. Every able-bodied man would contribute labor. The work might go on for weeks or months. And some communities would require each landowner to contribute a certain number of days of labor per year for road maintenance and construction, a practice called statute labor that was common in America through the mid-1800s. In other cases, corduroy roads were built by military forces or commercial enterprises. During the Revolutionary War and the War of 1812, armies built corduroy roads to move troops and supplies across swampy terrain. The roads were temporary, meant to last only for the duration of the campaign, but the construction techniques were the same. Soldiers would cut logs, drag them to the road site, and lay them across the swamp. An army moving through swampy country might build miles of corduroy road in a week, using hundreds of soldiers as labor. The military application of corduroy roads was particularly important in the South, where much of the terrain was swampy lowland. During the Revolutionary War, the British and Continental forces both built corduroy roads to move through the Carolinas and Georgia. The speed of army movement often depended on how quickly they could build road through swamp terrain. A particularly notable example was General William Tecumseh Sherman's Carolinas campaign in 1865 during the final months of the Civil War. Sherman's army of 60,000 men moved from Savannah, Georgia, through South Carolina and into North Carolina, a route that required crossing hundreds of miles of swampy terrain. The Army's Pioneer Corps, specialized engineer units, built corduroy roads ahead of the main force. The technique used by Sherman's pioneers was optimized for speed. They would survey the route, identifying the worst swamp sections that required corduroying. While the main army marched on existing roads, the Pioneer Corps would move ahead, cutting logs and building corduroy through the swamps. The goal was to have each section of corduroy completed just as the main army reached it, maintaining the pace of advance. Sherman's chief engineer, Captain Orlando Poe, recorded the corduroy construction rates in his after-action reports. A pioneer company of 100 men could typically build a quarter mile of corduroy road in a day under good conditions, faster if the timber was close to the road line, slower if logs had to be hauled from a distance. The entire Army's Pioneer Corps, working in parallel on multiple road sections, built approximately 50 miles of corduroy road during the Carolinas campaign, using an estimated 500,000 logs. The soldiers doing this work were not volunteers. They were detailed from line infantry regiments, typically on a rotating basis. A regiment might provide a company of men for pioneer duty for a week, then return to regular marching while another regiment took over. The work was unpopular, harder than regular soldiering, often done in swamps under enemy fire or threat of ambush. But it was necessary. Without the corduroy roads, the Army couldn't advance through the swamp terrain. The logging industry also built corduroy roads to access timber stands. A logging company would build a corduroy road from their cutting area to the nearest river or railroad. The road would be used to haul logs out of the forest on wagons. These logging corduroys had to be especially strong because they'd be carrying heavy loads, wagons loaded with logs that might weigh several tons. The construction would use larger logs, sometimes secured with wooden pins driven through adjacent logs to prevent them from shifting under load. One of the more famous corduroy roads in American history was the road built across the Dismal Swamp in Virginia and North Carolina. The Dismal Swamp is a vast wetland, originally about 2,000 square miles of swamp forest. In the colonial era, it was a major barrier to transportation between Virginia and North Carolina. There was no way to cross it with wagons or coaches. In the 1760s, a group of investors, including George Washington, organized the Dismal Swamp Company to drain and develop portions of the swamp. A part of this effort involved building a road across the swamp to facilitate transportation and commerce. The road was built using corduroy construction, logs laid side by side across the worst sections, with raised embankments where the ground was firm enough to support them. The Dismal Swamp Road took several years to build, using both hired labor and enslaved workers. The conditions were brutal. The workers were operating in a swamp, standing in water or deep mud, surrounded by mosquitoes, working in heat and humidity. Disease was rampant. Malaria killed numerous workers. Dysentery was common. Snake bites occurred frequently. The work was slow and exhausting. A worker named Samuel Perkins, who supervised a section of the Dismal Swamp Road construction in 1768, kept a journal that provides insight into the conditions. From July 1768. The work proceeds slowly. The men are constantly wet and covered in mud. The mosquitoes are unbearable. We have lost 2 men to fever this week. 3 more are too sick to work. We cut logs and drag them through waist-deep water to the roadside. Each log must be positioned precisely. The road sinks into the mud as we build it. We add more logs on top. It seems we make no progress, though we work from dawn to dark. Perkins' journal also records the technique used to stabilize the road. From August 1768, we have discovered that laying a foundation of brush and small branches beneath the logs helps prevent them from sinking as quickly. The brush distributes the load somewhat. We now cut both large logs for the road surface and masses of brush for the foundation. This doubles our labor, but improves the result. The technique Perkins describes, using a brush foundation beneath the corduroy logs, became standard practice in swamp road construction. The brush created a semi-rigid mat that spread the load over a wider area. It also provided some drainage, allowing water to flow beneath the logs rather than pooling on the surface. A good corduroy road might have 6 inches to a foot of brush foundation, then 12 to 18 inches of logs forming the surface. The total depth of construction might be 2 feet, all of it organic material that would eventually rot and need replacement. The travel experience on a corduroy road was notoriously uncomfortable. The logs were never perfectly level. Some would settle more than others. Some would be larger in diameter, creating high spots. And the wagon wheels would roll over the logs with a pronounced bump each time they crossed from one log to the next. The rhythm was constant, bump, 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 as the wheels hit each log in succession. The ride was so rough that corduroy roads were nicknamed Shake Your Bones roads. The physical sensation of traveling on corduroy was memorable for anyone who experienced it. The constant bumping would jar your entire body. Sitting in a wagon, you'd be bouncing continuously, unable to find a comfortable position. The vibration would make your teeth chatter. Objects in the wagon would shift and rattle with each bump. Holding onto the wagon sides was necessary, just to avoid being thrown out by the constant jolting. The speed of travel on corduroy was necessarily slow. A wagon might make 2 to 3 miles per hour on a good corduroy road, as compared to 4 or 5 miles per hour on a conventional dirt road. The slow pace was dictated by the need for horses to place their feet carefully on the logs, and by the danger of excessive bouncing breaking the wagon or injuring the horse. Travelers who kept journals frequently commented on the ordeal of corduroy roads. Francis Trollope, an English writer who traveled through America in the 1820s and 1830s, wrote extensively about her experiences on corduroy roads in her book Domestic Manners of the Americans. From her account, we came upon a road of logs laid across the swamp in the manner they call corduroy. The effect upon our wagon was extraordinary. We were shaken and bounced until every bone ached. The noise was tremendous, a constant rattling and bumping that made conversation impossible. After 10 miles of this torture, we emerged from the swamp bruised, exhausted, and grateful to be on conventional road again. Another traveler, Charles Fenno Hoffman, described traveling on a corduroy road in upstate New York in 1833. The corduroy road we struck was in wretched condition. Many logs had rotted and broken, creating gaps that our wheels would drop into with violent jolts. The driver had to navigate carefully, choosing his path to avoid the worst sections. Even so, we were thrown about mercilessly. My traveling companion, unaccustomed to such roads, became ill from the constant motion, and we had to stop frequently to allow him to recover. The danger of corduroy road travel was real. Wagon wheels breaking was common. The constant stress of rolling over logs, combined with sudden drops when hitting gaps or rotten sections, would crack wooden wheels or break iron tires. A broken wheel on a corduroy road, miles from any settlement, was a serious problem. The wagon would have to be unloaded, the wheel repaired or replaced, and the wagon reloaded, work that could take hours or even days if a replacement wheel had to be obtained. Horses and oxen also suffered on corduroy roads. Their hooves would slip on the rounded surface of the logs, especially when the logs were wet. A horse that lost footing could fall, potentially breaking a leg. A fallen horse pulling a loaded wagon was a dangerous situation. The weight of the wagon could drag the horse, cause it to panic, or injure the other horses in the team. Teamsters had to be constantly vigilant, watching their animal's footing and ready to stop immediately if a horse stumbled. The noise was also distinctive. The wooden wheels rolling over wooden logs created a hollow, knocking sound. The iron tires on some wagons would ring against the logs. A wagon train traveling over a corduroy road could be heard from a considerable distance, the rhythmic knocking and bumping echoing through the forest. At night, the sound of wagons on corduroy roads carried even further. Settlers living near a corduroy road would wake to the sound of wagons passing in darkness, the bump, bump, bump rhythm identifying the road being traveled even without seeing the wagon. Some described the sound as almost musical in its rhythm, though the music was insistent and jarring rather than pleasant. The maintenance requirements for corduroy roads were substantial. The logs would rot, especially at the bottom where they were in constant contact with wet ground. Rot could render a log structurally unsound in 2 to 3 years. The road would need to be rebuilt entirely every 5 to 7 years on average. Between complete rebuilds, individual rotten logs would be replaced as they failed. The failure of logs in a corduroy road was dangerous. A wagon traveling over the road might hit a rotten log that would break under the weight. The wheel would drop into the resulting gap. The sudden jolt could break the wheel, break the wagon axle, injure the horse, or throw the driver from the wagon. There are documented cases of deaths resulting from corduroy road failures, drivers thrown from wagons and trampled by horses, wagons overturning when wheels broke, loads shifting and crushing workers. In October 1832, once a teamster named William Hodges was killed on a corduroy road in western New York when his wagon hit a rotten log. The log broke, the wheel dropped into the gap, and the wagon overturned. Hodges was pinned under the wagon and crushed. His assistant, who witnessed the accident, reported, "The log gave way without warning. One moment we were traveling normally. The next, the wagon was on its side and Mr. Hodges was beneath it. We could not lift the wagon off him in time. He died before we could get help." The economic importance of corduroy roads in developing frontier regions cannot be overstated. These roads allowed settlement and commerce in areas that would otherwise have been inaccessible. Farmers could get their crops to market. Merchants could transport goods to frontier towns. Settlers could reach land that had previously been unreachable. The roads were expensive to build and maintain, but the economic activity they enabled justified the cost. In Michigan in the 1830s, the territorial government invested heavily in corduroy road construction to encourage settlement. The territory had vast areas of swampland, particularly in the lower peninsula. These lands were potentially valuable for agriculture if they could be drained and accessed, but transportation was impossible without roads. The government organized road building projects and provided some funding, though much of the labor came from settlers working statute labor requirements. One of the major corduroy roads in Michigan was the Chicago Road, which ran from Detroit westward toward Chicago. And portions of this road crossed extensive swamps and required corduroy construction. The road was built in sections between 1830 and 1835, using a combination of hired labor and statute labor from settlers. A worker named James Ingalls, who helped build a section of the Chicago Road in 1833, wrote to his brother in Massachusetts describing the work. From Ingalls' letter, dated August 1833, "We are building a road through the worst swamp I have ever seen. The ground is so soft that horses sink to their bellies. We have cut thousands of logs and laid them side by side across the muck. The work is backbreaking. My hands are blistered from the axe and saw. We work in mud and water constantly. The mosquitoes are beyond description, but the road is necessary. Without it, this land cannot be settled or farmed. We persevere." The Michigan corduroy road projects were ambitious in scope. The Chicago Road alone required approximately 50 miles of corduroy construction through the worst swamp sections. At 10,000 logs per mile, that's 500,000 logs. The timber came from the forests adjacent to the road line. Workers would clear swaths hundreds of feet wide on both sides of the road, cutting every suitable tree. The environmental impact was severe and visible for decades. Travelers in the 1850s reported passing through miles of cleared land with rotting stumps where forests had been harvested for road building. Another major corduroy road project was in Wisconsin, where the military built roads to connect Fort Howard at Green Bay with other posts in the region. The Fort Howard Road, constructed in the 1830s, and crossed extensive marshlands around Green Bay. The military used soldier labor supplemented by civilian contractors. A civilian contractor named Ezra Thompson supervised a section of the Fort Howard Road construction in 1834. Thompson's account book, preserved in the Wisconsin Historical Society, records the details of the work. The project employed 40 men for 6 weeks to build 3 miles of corduroy road. They cut and laid approximately 30,000 logs. Thompson's notes indicate they were paid by the mile, $50 per mile of completed road, equivalent to about $1,500 in modern currency. From that, Thompson had to pay his workers, typically $1 per day, and provide food and tools. His profit margin was slim. Thompson's notes also record the challenges of the work. From June 1834, "The swamp is deeper than we anticipated. In some places, the muck is 6 feet deep. We are laying multiple layers of logs to create a stable foundation. The first layer sinks into the mud as we place it. We add a second layer on top. Sometimes a third is necessary. This triples our labor and uses far more logs than contracted. I will lose money on this section." The technique Thompson describes, layering logs to create stable foundation in deep swamp, was common where the ground was particularly soft. A single layer of logs would simply sink and disappear into the muck. By placing multiple layers, each one distributing load over a wider area, eventually you'd reach a configuration that was stable. But this dramatically increased the timber requirements. A section that should have used 10,000 logs per mile might require 20 or 30,000 with multiple layers. In the Deep South, corduroy road construction often used enslaved labor. Plantation owners in coastal Georgia, South Carolina, and Louisiana built corduroy roads through their properties and to connect with public roads. The work was done by enslaved people who received no pay and had no choice about whether to participate. The conditions for enslaved workers building corduroy roads were particularly brutal. They were working in southern swamps, some of the worst environments in America. The heat and humidity were intense. The mosquitoes carried diseases including yellow fever and malaria. The work was hard physical labor, cutting logs, dragging them through swamps, positioning them. And unlike free workers who could quit if conditions became unbearable, enslaved workers had no such option. Records of enslaved workers' experiences with corduroy road work are scarce because enslaved people rarely had the opportunity to leave written accounts. But occasional mentions in plantation records and in accounts by visitors provide glimpses. A visitor to a South Carolina plantation in 1845 wrote in his diary about observing road work. The plantation owner has set his people to building a corduroy road through the swamp to connect with the public road. 30 men are engaged in the work, cutting cypress logs and laying them in the swamp. They work from dawn to dark in waist-deep water, surrounded by snakes and alligators. The overseer drives them constantly, allowing no rest. The conditions are appalling. The lack of compensation and the brutal conditions meant that enslaved labor could be used in ways that would have been economically impossible with free labor. A free worker earning $1 per day represented a cash cost. An enslaved worker represented no cash cost to the plantation owner beyond minimal food and shelter. This economic reality meant that corduroy roads in the South were often more extensively built than in regions relying on free labor, simply because labor costs weren't a limiting factor. The Chicago Road and others like it opened Michigan to settlement. Within a decade of the road's completion, the population of Michigan had increased dramatically. Towns sprang up along the road. Farms were established on land that had been wilderness. The corduroy roads, and despite their roughness and need for constant maintenance, made economic development possible. The decline of corduroy roads came with the development of better road-building technologies and drainage techniques. By the mid-1800s, engineers had learned to drain swamps more effectively, lowering the water table enough that conventional road building became possible. Gravel roads with proper drainage could be built where corduroy had once been necessary. By the late 1800s, plank roads, made from sawn lumber rather than round logs, offered a smoother alternative for wooden road construction. The automobile era finally made corduroy roads obsolete. Automobiles couldn't handle the rough surface. The bumping from log to log would damage the vehicle. The uneven surface made steering difficult. As automobile traffic increased in the early 1900s, corduroy roads were either paved over or abandoned in favor of new roads built to better standards. Today, very few corduroy roads survive in their original form. Most have rotted away or been replaced by modern roads. A few sections have been preserved as historical curiosities. The Corduroy Road in the Adirondack Mountains in New York is a preserved section showing original construction. It's now a hiking trail, allowing people to walk on logs laid over 100 years ago and experience what travel was like in that era. Occasionally, corduroy roads are discovered during modern construction. When workers excavate for a new road or building foundation in an area that was once swamp, they sometimes find layers of logs buried in the soil, the remains of old corduroy roads. These archaeological finds provide physical evidence of the scale of corduroy road construction and the techniques used. The labor involved in building America's corduroy roads was enormous. Tens of thousands of miles of corduroy roads were built over the 200-year period when they were the primary solution for crossing swamps. At 10,000 logs per mile, that represents hundreds of millions of logs cut, hauled, and laid by hand. The workers who did this labor were settlers, soldiers, enslaved people, hired laborers, whoever was available and could be pressed into service for the arduous work of swamp road construction. These workers operated in some of the most difficult conditions imaginable. Swamps are hostile environments. The standing water breeds mosquitoes and other insects. Disease is prevalent. The heat and humidity are oppressive. The footing is treacherous. And the work itself, cutting logs, dragging them through mud and water, positioning them precisely, required sustained physical effort that left workers exhausted. The pay for corduroy road work was typically minimal when workers were paid at all. Much of the labor was unpaid, statute labor from settlers who were required to contribute time to road building, or enslaved labor from plantation owners who would send workers to satisfy their community obligations. When workers were paid, the rates were usually comparable to other manual labor, $1 to $2 per day in the mid-1800s, enough for basic subsistence but not much more. The mortality rate for corduroy road construction is difficult to establish because records are incomplete. And we know that disease killed many workers, particularly in southern swamps where malaria and yellow fever were endemic. We know that accidents killed others, crushed by falling trees, drowned in swamps, injured by tools or equipment, but the total numbers are lost to history. Most corduroy road workers were anonymous laborers whose lives and deaths went unrecorded. What remains is the infrastructure they created, the network of roads that opened swamp regions to settlement and commerce, the economic development that followed, enabling towns and farms and industries to establish in areas that had been wilderness. And the memory, preserved in place names and historical accounts of the corduroy roads that made it all possible. Walking on a preserved section of corduroy road today, you experience something of what travel was like in the era before modern road engineering. The uneven surface, the give and shift of logs under your weight, the gaps between logs where rainwater has eroded the foundation. It's immediately obvious that this was a challenging surface to traverse, even on foot. Imagining a heavily loaded wagon rolling over this surface, the horses struggling for footing, the driver fighting to maintain control, it becomes clear how difficult and dangerous travel was on these wooden highways. The corduroy road represents a particular moment in American transportation history. A solution to a specific problem, how to cross swamps before modern engineering made drainage and stable roads possible. The solution was simple, labor-intensive, and effective within its limitations. 10,000 logs per mile, cut by hand, laid by muscle power, creating roads that would last just long enough to be useful before needing to be rebuilt entirely. The workers who built these roads, the James Ingalls standing in Michigan, swamps cutting logs, the Samuel Perkins supervising construction in the Dismal Swamp, the thousands of unnamed settlers and laborers and enslaved people who contributed their labor to America's corduroy roads, they built infrastructure that made settlement and commerce possible in difficult terrain. They did it with axes and saws and ox teams. They worked in mud and water and heat. Many died doing it, and most are completely forgotten. But the roads they built opened the country. The swamps that had been barriers became crossable. Settlement advanced, commerce expanded. The economic development of vast regions depended on these rough, uncomfortable, constantly failing wooden roads that had to be rebuilt every few years. That was the cost of progress in swamp country. 10,000 logs per mile, all cut and laid by hand, roads built from forest floors, connecting settlements across terrain that would have been otherwise impassable. The next time you drive across a modern highway that crosses a wetland area, consider what that land was like before modern road building. Consider that crossing that same distance might have required building a corduroy road, thousands of logs cut from nearby forests, laid side by side across the soft ground, creating a rough wooden surface that wagons could traverse. Consider the labor required, the workers who did it, the communities that organized and funded the effort. And consider that this was how America crossed its swamps for 200 years, until better technology made corduroy roads obsolete. The corduroy roads are mostly gone now, rotted away, paved over, replaced by modern infrastructure. But they were real. They existed by the thousands of miles. They required hundreds of millions of logs and untold amounts of human labor to build and maintain. They made settlement and commerce possible in swamp regions across the country. And they're almost completely forgotten, known today mostly as a curious footnote in transportation history rather than as the critical infrastructure they actually were. That's the story of America's corduroy roads, 10,000 logs per mile, wooden highways crossing impossible terrain, built by hand in swamps and wetlands, rough, uncomfortable, so constantly needing repair, but functional enough, reliable enough, useful enough to serve for the decades or centuries until better roads could be built. Infrastructure that's invisible now, rotted away, or buried under later construction, but infrastructure that mattered, that enabled development, that connected communities. Built by workers whose names we'll never know, from forests that were cleared entirely, creating roads that allowed America to expand into terrain that should have been impassable.